Hello everyone. In this lecture, we will see complementary metal oxide semiconductor, and generally we use CMOS term to indicate complementary MOSFET. CMOS is a combination of PMOS and NMOS. Okay, so CMOS is a combination of P-type MOSFET and N-type MOSFET. In a simple designing, we can understand how we can design CMOS. You have to keep your PMOS at the top and NMOS at the bottom. At the top of PMOS, you have to provide the VDD, and at the bottom, you have to provide the ground, GND. From the center, we can take the output that will be Vout. That is the simplest design by which we can explain how we can design the CMOS with the help of PMOS and NMOS. We have to keep the PMOS at the top and NMOS at the bottom. Now, after this, we will see how we can design any circuit with the help of PMOS and as well as by using the NMOS. After that, we will combine both the circuit and we will create one CMOS type of circuits. So let's see first PMOS. So first we will see the symbol that we use for PMOS. So here we use one bubble to indicate it's a PMOS. P indicates holes, and for holes we use this bubble sign. And from here we can provide the input. At the top you have to provide the VDD. And always remember, we have to take the output near to ground in PMOS. The Vout will be taken near to ground. I will also explain NMOS parallelly, so we will have a clear idea what is the meaning of PMOS and what is actually the NMOS. So here I am drawing the NMOS symbol. So here this is the NMOS symbol. Here we don't use bubble because it's the N type of MOSFET. And here we will provide the input. This is the VDD. And at the bottom, we have to connect to the ground. Okay. The important point to note is what? We have to take the output near to VDD in case of NMOS. So here the output will be taken near to VDD in case of NMOS, and in PMOS, we have to take the output near to ground. Now we will see the condition on which our PMOS will be on or off. Okay, so here I am writing the input and this is the PMOS. So there is only two possibilities. Either we will give the input as 0 or I will give the input as 1. If you are giving input as 0, so PMOS will be on. On, or in other word, I can say it's just short circuited. Similarly, if I provide 1 or high, then it will be off and I can say it is the open circuited. Similarly, parallelly, we will see NMOS also. Here also we will see the condition of input and NMOS is off or on. So again, there is two possibility, either input is 0 or 1. If it is 0, then NMOS will be off, or I can say it is open circuited. And if it is 1, input is 1, then it will be on and it is a short circuited. Okay, so this is the basic thing that we should know. Then we will see the functionality of PMOS based on different types of input. So let's see PMOS first. So here I'm starting with a PMOS. In the PMOS, as we know the symbol, so here I'm using one bubble and here I will provide the input. Here I'm connecting to the VDD. This is VDD. And at the bottom, we need to connect to the ground. The important point, as you know, we have to take the output near to ground. This is Vout. Okay. Now, here, as I told you, if this is the input and this is the condition of PMOS 0, 1, okay. PMOS is on. If it is on, right, on, I can say it's a short circuited, right? It is a short circuited. So I'm just using different color to tell you in a different way. Okay. So if I'm saying input is 0, PMOS is on or short circuited. If it is a short circuited, that means it is connected like this. So V out is connected to what? A VDD. So the output V out equals to VDD, or I can say 1. Always remember VDD or 1, and ground is equivalent to 0. So when I am saying input is 0, PMOS is on or short circuited, so that V out is directly connected to VDD and the output is 1. Clear? Now I am using some different color to tell what will happen if we give input as 1. Now I am giving input as 1. If input is 1 and as we know that PMOS is off, off means what? Open circuited. If it is open circuited, that means it is now not connected, right? It's not connected. Then V out is connected to what? Ground, right? So V out is connected to ground and output is 0, right? So now you see when we are giving input as 0, I am getting 1 in PMOS. And when I'm giving input as 1, I am getting 0 as an output. So it is similarly working as an inverter, complement, right? So the circuit, the PMOS will work as an inverter. So here I will write down it is inverter, PMOS inverter. Whenever I am giving 0, I am getting 1. When I'm giving 1, I am getting 0. Now, after this, we will see the NMOS functionality also. So here I'm drawing NMOS circuit. As you know the symbol, so I'm not explaining it again. Here we have to provide the input. This is input. And here we will give the VDD, and this is the ground. And the important point to note is what? From the near to VDD, we have to take the output. This is our V out. Now we will see the how the NMOS will work. Here I'm taking input. This is NMOS, and we will check the output. Correct. So input can be either 0 or 1. If it is 0, that means it is off. Off means what? Open circuited, right? So it is open. Now here I am taking input as 0. NMOS is what? Open circuited like this. There is no connection of V out with the ground. There is only a connection of V out with what? VDD. So I can say this is VDD, or I can say 1. Both are same thing. Now I will take the another possible input. That means if input is 1, what will happen? If input is 1, if NMOS will be what? On, or you can say short circuited, right? If it is short circuited, like this, okay. So V out have a direct connection to what? Ground. So now V out will be equals to ground or 0. Here also you can check, if you are providing 0, you are getting 1. If you are giving 1, then we are getting 0. That means NMOS is also working as what? Inverter. So we have seen the functionality, how the PMOS is working and NMOS is working. For example, we need to design any circuit with the help of PMOS and NMOS, how we can do that. So next part we are taking. Here we are seeing, we will check designing of design NAND gate, for example, design NAND gate using PMOS. Okay. So if you want to design any circuit, any expression, then first you write down the expression for that gate. So here we need to design NAND gate. So how I can write down? For example, y is equals to a dot b whole bar, right? PMOS is already an inverter. Okay. We have seen if you are drawing any type of circuit for PMOS, it will work as an inverter, right? So that means all the PMOS and NMOS are inverters only. That means already bar is there. We have to focus on this dot, right? So here for AND functionality, connect PMOS in parallel. Connect PMOS in parallel. And for OR functionality, connect PMOS in series. Clear? This point is very important. For AND functionality, connect PMOS in parallel. And for OR functionality, connect PMOS in series. Right? So now, as we can see in the expression, we require this AND operation, right? And this bar is already there in PMOS because PMOS is our inverter, right? So here we have to connect the PMOS in parallel. Connect PMOS in parallel. So here I'm drawing two PMOSes in parallel like this. And here I will give A, here I will provide B, and connect it like this, connect it like this. At the top, we have to provide with a VDD. At the bottom, you have to connect to the ground. Always remember, you have to take the output near to ground in PMOS, right? So here we will connect to the Vout. This is the NAND gate by using the PMOS. We can check the functionality by assuming this is, for example, Q1. Okay, this is, for example, Q1 and this is Q2. I'm just taking to explain you the working, how it is working as a NAND gate. Okay, so here you see how we will start this one. Here I am assuming this is my input A, this is my input B, and these are the MOSFET. Okay, so this is Q1, this is Q2, and we will check the Vout. Now, as you know, if you have the two inputs, A and B, there will be four possible combinations: 0, 0, 1, 1, 0, 1, 0, 1. Right? We know that PMOS will be on if input is 0. Right? So here I'm writing this is on, because it's B is 0. Right? This is on, this is off. Clear? If it is 1, then off. 0 means on, off, off. Right? Now you see, when I'm saying it's on means what? It's a short circuited, right? So this is short circuited. Q2 is also short circuited. V out is connected to what? V out is connected to VDD. So the output will be VDD. If Q1 is on and Q2 is off, that means it's open circuited, but V out is anyhow connected to VDD, right? So that means V out is equals to VDD. If any of the MOSFET is on, then output is VDD. Only when both are off, then both are open circuited. That means V out is not able to connect to VDD. Then the output will be connected to ground, and output is GND, or you can write down 0. Okay, 1, 1, 1, 0. So you can see by the truth table also that this circuit is working as the NAND gate circuit. Now, with the help of PMOS, we will design a NOR gate, right? So here we will see how we can design a NOR gate using PMOS. So as I told you, if for the OR operation, for OR functionality, they will be connected. That means PMOS will be connected in series, right? So PMOS will be connected in series. So first we will write down the expression of a NOR gate. That means Y is equals to A plus B whole bar. But don't focus on the inverter because PMOS is already an inverter. Okay, PMOS is already an inverter. Now focus on this plus sign, and this plus sign is what? Or functionality. That means PMOS will be connected in the series like this, here in this way. So here I am giving this is A, here I am giving as B. At the top, you have to provide with VDD. At the bottom, it is ground. And you know that when you are designing the circuit with PMOS, the output will be connected to what? Near to ground. So this is V out. The same we can check with her truth table, right? So here I am considering this is Q1 and this is Q2. So here I'm taking A, B, this is Q1 and this is Q2. We will check the V out. So here, as we are having two inputs, total four possible combinations will be there: 0, 0, 1, 1, 0, 1, 0, 1. You know that both are the PMOS. So if it is 0, 0, then it will be on. So on, on, off, off, on, off, off. Why? Because PMOS will be on if the input is 0, right? And it will be off if the input is 1. Now, if both are on, if both are on, if first condition I am checking, if A and B both are 0, 0, Q1 and Q2 both are on, that means they are short circuited like this, and V out is connected to what? VDD. So the output will be VDD here. But if any of the MOSFET is off, then V out is not able to connect to VDD, then V out will be connected to ground. That means 0 or GND. So here also it's 0. If both are off, that means this in this condition also V out cannot reach up to VDD. So V out will go to the ground and the output is 0. So now here you see this functionality is working as a NOR gate. Okay. Now this is how we are designing some universal gates with the help of PMOS. Let's see how we can design some gates or some functionality by using the NMOS. So here we will see design. First, we will see the NAND gate. Okay, design NAND gate by using the NMOS, using NMOS. So in this condition, first we will see how we can connect the NMOS. So for OR functionality, NMOS will be connected in parallel. Similarly, for AND functionality, NMOS will be connected in series. NMOS will be connected in series. Correct. Now we are actually trying to design a NAND gate circuit by using the NMOS. So we will write down the expression here. So A dot B whole bar, right? This is that NMOS is also a inverter. So don't focus on the bar. Only you see the expression A dot B. A dot B means what? Is the AND functionality. And the NMOS will be connected in series, right? So NMOS will be connected in series for NAND gate. So here I'm giving A here, I'm giving B here, and this is connected to VDD. This is connected to ground GND. The point to remember is what? Always take V out near to VDD in case of NMOS. So this is V out. Clear? Now to check the functionality, we will again assume the Q1 and Q2 to understand whether it's working as a NAND gate or not. So here I am assuming this is Q1 and this is Q2. And here I'm taking A, B. This is Q1 and this is Q2. And we will check the V out. So 0, 0, as we are having two inputs A and B, there will be four possible combinations: 0, 1, 0, 1. And as we know that for a 0, it will be off because it's a NMOS. Off, on. On in case of 1. So on, off, on, on. Right? Now, if both are off, if both are open circuited, then V out is connected to what? VDD only. So the output is VDD. If anyone is off, if anyone is off, then also V out cannot reach up to ground. So V out will be connected to VDD. VDD. If both are off, if both are on, sorry, if both are on, then V out have a direct path to ground and the output will be GND, or you can say 0. So 1 1 1 0. So now you can see that this NMOS circuit is behaving just like a NAND gate. Now we will see how to design a NOR gate, design NOR gate using NMOS. So we will start with the expression first. So here I am writing y is equals to a plus b whole bar. As we know that if it is a or operation by using NMOS, they should connected in parallel. Okay. So here we will connect these NMOS in parallel like this. Here I am giving A, here I am giving B, and this is VDD, and here at the bottom I will connect to ground GNT. As we know that in case of NMOS, V out will be taken near to VDD. So this is V out. Now, to check the functionality, again, we will make a truth table here. So I am assuming this is Q1 and this is Q2. So that will give us an idea how is working as an OR gate. So I'm assuming this is Q1, this is Q2. Here I'm taking A, this is B, this is Q1, this is Q2, and we will check the V out after that. So as we are having two inputs, 4 possible combinations will be there like 0, 1, 0, 1. And as you know, this will be off because in NMOS, if you are providing 0 as an input, it will be off, 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 on, off, on, on. If both are off, then V out will be connected to the VDD because both are off. So it will be connected to VDD. If either of the NMOS is on, then V out will have a path to ground and it will be GND. If either of it, okay. But if both are on, then V out have a connection with a ground. So this is also GND. So I can write down 1 0 0 0. So this is that is how this circuit is working as a NOR gate. Now we will see how to design a NAND gate by using CMOS. So before going for the designing, okay, let's see how we can design NAND gate. For example, you have to design the NAND gate using CMOS. So we have seen how to design by using the PMOS. We have also seen how we can design the NAND gate by using the NMOS. What we have to do, at the top, you have to draw the PMOS circuit, whatever we have seen. At the top, we have to connect to the VDD. At the bottom, you have to connect to the NMOS circuit, as we have seen earlier also. At the bottom, connect to the ground. From the center, you take the output. Why? Because we know that from the bottom of the PMOS, we are taking the output, and from the top of NMOS, we are taking the output from the NMOS, right? So here, what we have to do, you have to draw the PMOS circuit at the top and NMOS circuit at the bottom, right? So let's see if you want to design the NAND gate, how we will start it. So first you write down the expression, that is A dot B whole bar. As I told you, the circuit is an inverter. Okay, so just focus on the dot operation. So it's the AND operation, right? So as we know that for the AND operation, PMOS will be connected in parallel. Okay, as we know that PMOS will be connected in parallel for the AND operation. So here I am drawing two PMOS in parallel, and I am saying this is A and this is B, and this is what a VDD, and at the bottom, at the bottom we have to draw the NMOS circuit. In the NMOS circuit, we know that for the AND operation, the NMOS should be connected in series like this. So here I am drawing two NMOSs like this. This is A and this is B. At the bottom, it is GND. From the center, you have to take the output. This is V out, right? So this is the complete CMOS circuit, and which is working as a NAND gate. Okay. Now you can again check the functionality here. For that, you have to take A, B, and as here we are having the four MOSFETs. Assume this is Q1, this is Q2, this is Q3, and this is Q4. Okay, so here I am assuming this is Q1, this is Q2, this is Q3, and this is Q4. And we have to check the output, V out. As we are having two inputs, there will be a four combination 0, 0, 1, 1, 0, 1, 0, 1. And as this is a PMOS, it will be on for 0, on for 0. But these will be off, off, off. Understand? Because this is a 0, 0, and Q3 and Q4 are the NMOSs. 0, Q1 will be on, Q2 will be off because it's 1. It is off, on. 1, PMOS will be off, 0, on, off. For 1, 1, it is off, on. Now you see, when we are giving 0, 0, right? So 0, 0 means what? Both are short circuited. Just change the color so to tell you in detail. So for example, I am giving 0, 0 as a input. If this is 0, Q1 is on, that means short circuited, short circuited. V out will be connected to what? And both these Q3 and Q4 are off, that means open circuited. So V out will have a direct path to what? To VDD. So this is the VDD. If Q1 is on, if V out Q1 is on, that means short circuited, it will go up to what? A VDD. And this is off. Okay, this one Q4 is Q3 is off, so V out cannot reach up to ground. But as any of it is on, V out can reach up to what? VDD. So it's what? VDD. Similarly, any means VDD. Now, if both are off, these are off, that means open circuited, and Q3 and Q4 are on. So V out will have a direct path to ground. So this is what? A ground. So this is the way by which we can design a NAND gate by using the CMOS. I will also tell you how to design a NOR gate. Design a NOR gate using CMOS. So first I will write down the expression here. Y is equals to A plus B whole bar. As we know that complementary MOSFET is a complement already inverter, we have to draw the PMOS circuit at the top. So for the OR operation, it will be connected in series. So in series PMOS like this. This is A and this is B with bubble. I'm telling this is a PMOS. And for OR operation, by using the NMOS, it should be connected in parallel like this. So this is A and this is B. At the bottom, it will be a ground GND. From the center, we have to take the output. This is V out. At the top, we have to connect to the VDD. And this is the circuit for the NOR gate. Now, Again, we will check the functionality by making the truth table. Here I am taking A, B, Q1, Q2, Q3, and Q4, and we will check the V out. Assume this is Q1, this is Q2, this is Q3, and this is Q4. As we are having the two inputs, there will be four possible combinations: 0, 0, 1, 1, 0, 1, 0, 1. As this is the PMOS, it will be on, NMOS, off, on, off, on, 1, so it's off, 0, on, off, it's off, on. Now you see, for the first condition, when both are 0, 0, and this is on, that means now the V out will be connected to VDD, right? Because both are short circuited and it's open circuited. So V out will be connected to VDD. Similarly, if it is any of it's off, that means V out cannot reach up to VDD, because any of is open circuited, V out cannot reach up to the VDD. So V out will be gone to the ground, and this is GND. Any GND. If both are off and any of it's on, that means V out will be connected to ground. So now you can see 1, 0, 0, 0. It is working as a NOR gate. Now, if we simply connect PMOS at the top and NMOS, so it will work as a inverter. Let's see CMOS as a inverter. How we can use CMOS as an inverter? So as for the inverter, I can write down Y is equals to A bar, correct? Okay. So as you know that at the top, we have to draw the circuit by using the PMOS. So I am drawing it by the PMOS like this. This is PMOS. And I am giving A here. At the bottom, we have to draw that by using the NMOS. At the top, you have to provide with a VDD. At the bottom, you have to provide with a ground. Okay, clear, right? Now from the center, you have to take the output. This is V out. And as I told you earlier also, inverter is already there with NMOS and PMOS, so it's an inverter only. Now we will see the functionality, what is actually happening here with the help of truth table, right? So here I am taking the input as A, and assume this is Q1 and this is Q2. So this is Q1 and this is Q2. And we will check the V out. A can be either 0 or 1. It can okay, if it is 0, then it will be on because Q1 is PMOS, and this will be off because Q2 is NMOS. Q1 is off if it is 1, and Q2 will be on if it is 1, right? Now if Q1 is on, okay, let's see with some different color, so it will give you idea. If it is 0 and Q1 is on, that means short circuited, V out is connected to what? VDD, so the output is VDD. Clear? If it is 1 and Q2 is on, then V out will be connected to what? A ground, GND. I can say this is 1 and this is 0. Now you see, if you are providing 1, it is working as giving us output 1, and if you are giving 1, you are getting 0. It is working as a inverter or complement. That's why CMOS in normal, if just connect PMOS at the top and NMOS at the bottom, it will work as the inverter only. That's why we generally say CMOS is working as an inverter, or that's why its name is complement metal oxide semiconductor. And in next lecture, we will see how we can solve multiple type of equations and Boolean function by using the CMOS. That's all for this lecture. Thank you, everyone.